Hey guys, welcome back. Now before you start freaking out because, oh my gosh, it's word problems, we're all going to die, these are actually very easy word problems that you just have to look at what you're dealing with. You're always going to be given a number, sometimes a little bit extra numbers, but then a percent. So we have here the world population in 2000 was approximately 6.08 billion. The annual rate of increase was about 1.26%. So for the first part, we want to find the growth factor for the world population. So that means we're trying to find B. So as we did yesterday, we're going to take our 1.26% and we're going to change it to a decimal by moving 2 places to the left, which means that it's 0.0126. And then it says rate of increase. So we're going to add that to 1. So we've got 1.0126 for our B value. So then B says, suppose that rate is going to continue to be 1.26% every single year. Obviously that's not realistic because we have different rates of growth and birth and death and all that fun stuff. So we want to write a function to model the world population. Remember that that function is y equals a times b to the x, where x is your time in years, a is your starting value, y is your final value, and b is your rate of change. So y will always be y. A is 6.08.
But don't we have to put all the extra zeros on there to make it a billion?
That's a good question. You could if you really wanted to. Unfortunately, because 6.08 billion is 6,080,000,000, when you start multiplying that out, even though 1.0126 isn't that big, you might run out of space on your calculator, and then you're going to get scientific notation, and then you're going to freak out even more. So instead, we leave it at 6.08, knowing our answer is going to be in the billions, and then what we do is whatever answer we get, we just tack the word billion onto the end of it. Nice and slick. So we have 6.08 times our B value of 1.0126. to the x power. X and y are variables, so we leave them as such. So that's B. Now in part C, it says, let x be the number of years past the year 2000. Find the world population in 2010. That's code for stick a number in for x and solve for y. Well, 2010 is 10 years past 2000, so x equals 10. So that means we've got y equals 6.08 times 1.0126 to the 10th power. So now I've got written down exactly what I need for work, and now I can just calculate it into a calculator. And what do we get?
6.891008883.
So what we do is we say, okay, we started with 6.08, 2 decimal places, so we're going to go with 2 decimal places at the end. So 6.89 billion. And so 6.89 billion, if you want to add people, or PPL for people on the end, that would be awesome. So then we go to our next problem. We have a computer valued at $6,500. It's going to depreciate at a rate of 14.3% per year. We need to write the function. So I skipped that first little piece, but that does still mean we need to find B. So 14.3%, we move the decimal 2 places to the left. It is depreciating, which means the value is going down. So that means we need to take 1 minus 0.143, which gives us a B value of what?
0.857.
Which means that when we do our function, we get y equals, our starting value is $6,500. It's quite the computer to be starting at that value. Times our B value is 0.857 to the x power. Part B says now we want to find the value of the computer after 3 years. And if you were thinking about it, yep, you guessed it. 3 is our x. So now we're going to write out y equals 6,500 times 0.857 to the 3rd power, which 0.857 to the 3rd power, we're not so much worried about what that is since we have to round it anyways. So we put that in, and then we take that right away times 6,500, and what do we get?
$4,091.25.
And we get 0.248, and so we rounded it up to 25 cents. That's it. Showing you an example of increasing and an example of decreasing. So now, as you might have thought, that's what you have to do. So we have this first one with the population of a certain animal species decreasing at 3.5% per year, starting with only 80 in the habitat. Write the function. What will the population of animals be in 7 years? And then we got the population of Tokyo, Yokohama, Japan at just under 28.5 million in 2005, and was projected to grow at an annual rate of 1.1%. Find the growth rate multiplier, write the growth equation, and then predict what the population will be in 2020. And as always, write your summaries and bring your questions with you to class.